Good afternoon, everybody. Welcome back to the FIWARE I4 Trust training camp. This is a slight change to the schedule because the presenter who's going to be doing the security section, which was scheduled for today, is unfortunately he's busy with an urgent family matter. So I'm moving up from the Thursday session to the Wednesday session to continue on this set of training courses for NGSI-LD and various other aspects around data exchange and what we're going to be doing. Now, the same thing will apply as yesterday, in that this particular slot nicely splits into two halves, so there will be a break in the middle when I'm going to change my slide deck. Also attempting to get the video running directly on screen without me coming out each time. So let's see whether that bit works. I'm still learning how to use AirMeet, as I hope you're learning how to use FIWARE. So let's have a quick look at what we're going to be covering over the next 2 or 3 hours. Okay, when you are dealing with IoT agents and you are talking about NGSI-LD, the very first thing you need to think about in any linked data system is that you need to have your own implementation-specific @context file. This is the big difference, the big change between NGSI v2 and NGSI-LD. It's actually the same difference between plain old JSON and JSON-LD as well, is that @context is the only way that you can refer to the long names of things. And when we're talking about devices, and this is the area I'm dealing with for the first half of this session, you are usually going to be dealing with the FIWARE device data model as the basis of your devices, or you may have some alternative IoT model. For example, I think schema.org have got one. They've got IoT.schema.org has got things, but device model is very generic in the smart data models, the old FIWARE FIWARE devices. There is also an alternative called, I believe, multi-device, which the difference being that a device measures something and a multi-device does more than that, but so it's more complex and may well suit your needs if you've got some sort of more intelligent devices. Now, just because you have a model called device doesn't mean you can't actually extend it or override it. And indeed, part of the existing specification of NGSI-LD is adding in multi-typing. I believe that's it's either in 142 or it's due in 152, so that you could, for example, have a specific type of device. So you would have device, and then you would have, say, in this screen, we've got these examples of filling level sensor, or cow collar, or temperature sensor, or indeed a tractor, which would potentially have a lot of device in there. It would certainly have all the mandatory fields of device. This is one of the reasons why the smart data models don't have many mandatory fields, because obviously it gives you the flexibility to say, I am both a temperature sensor and a device, and device has got standard attributes like battery level, or device state, or operating system already in there if you need to use them. There is an attribute called reading, I believe, which is the raw value which comes in, but typically to be more useful in a real world scenario, you would need to have on the additional to the device model, you would need to have something describing the bits and pieces you've got. So in the case of a thermometer, you may well use have a temperature attribute, obviously, and there would be ontologies out there which are already describing what the a temperature really is, and long IRI for that. So for the example on the screen is here, it's a SAREF temperature. You can get ones which are more specific. You can get one for soil temperature if you're looking within the agricultural domain. But all of these values here, like filling level or temperature or luminosity or turbidity or what have you, are already defined by other ontologies. So the first thing to do is to find out what is my base model. I would definitely suggest use the Smart Data Models device if you have no preference for doing something else for good reason. But also use the ontologies, and this is where the search function of Smart Data Models actually comes across as being really useful, because you can find out, is there something out there which is already using temperature, already using filling or what have you. If you notice, particularly on the scenario I'm going to be dealing with at the moment, heart rate, for example, is not one of the standard things that most common IoT installations would actually deal with. So there's nothing in the existing Smart Data Models domain, or indeed SAREF, or indeed Schema.org or GS1 or a lot of other providers. So you need to start looking around. And what I did here is I found that there's a different ontology here in eHealth, which is the bio ontology from Perl, and I can refer to that as my IRI for this, because I don't want to make up, my own custom attribute heart rate, because heart rate is something which is already out there. That being said, it is obviously, if necessary, you can continue with adding in your own custom stuff. And I've got custom attribute 1, custom attribute 2 on this particular slide. The way to do this, as you can see on the bottom right, you go whatever your domain is, whatever the name of the attribute you want to call it. The reason why that works is because right up on the top, after the other ontology providers which I have listed, like FIWARE, like Schema.org, I've put example. And example is the one who's going to be replaced in the @context file with the full path for what is hopefully a URL, something which you can actually resolve to and actually find out more information for. But failing that is at least an IRI, which means that you can say that this is a unique what have you. The advantage of pushing your data models to somewhere like Smart Data Models or Schema.org or whatever is that if I find I have a particular strange thing which I am now measuring, and I've given it a reasonable sounding name, then hopefully other users of this system will start using the same naming convention. Obviously, it doesn't matter what the short name you have is, but it really, really does matter that the IRI is meaningful across multiple systems. The point being that you must, and I can't emphasize this enough, think none of this data is mine. You must think that the data in question is actually all potentially going to be shared, and therefore it needs to be placed into the mapping needs to be placed in the context file you are hosting. As I mentioned yesterday, if you fail to put something in the context, which can be possible, then it will default to the default context, which is the Etsy default context, which can be usable for things like actuations, for example, because that's not something you're particularly passing around. So it doesn't really matter if you call it something else, because no one else is going to be pushing stuff to your devices. But on the whole, best practice is put everything in there. Also include the metadata attributes, the properties of properties. So you'll notice there's something like accuracy in there because I've got an accuracy of my reading, which is obviously data about my data. You don't need to include sub-attributes of an object, because that's actually already defined by the object itself. But it is necessary when you're talking about properties of properties or relationships with properties. When you are configuring an IoT agent is here to translate a known protocol. Say, for example, it's JSON, or it's a LoRa message, or it's a set of binary bits and bytes, which is done through Sigfox or whatever. It's a known format, and it is translated in the IoT agent into a message which can then be passed into a context broker. The whole point of this FIWARE NGSI interface is that it decouples whatever's out there in the real world, abstracted out. You're not worried about whether it's a LoRa network or a Sigfox network or OPC UA or whatever. It's just as far as the context broker and everything above is concerned, it's all NGSI. But obviously that's not the case in the real world itself, and you need to have this translation layer, which is what the IoT agent does, or equivalence, because of course you could, if you wanted to, create your own IoT agent or have some processing component which, say, reads in a file or whatever. And the IoT agent has obviously got configuration. By default, there is a config.js file in the root of the image. You could, of course, if you are using Docker, you could actually override that by putting in a volume setting. But my personal preferred way of configuring an IoT agent is through the environment variable settings, which you can put when you are instantiating something through, say, Docker Compose. The advantage of this, of course, is that the environment variables in Docker are exposed, so you can see that the what the values are if you are inspecting it. Which also, of course, has a negative point in that if you have anything you want to secure, like usernames and passwords, you need to use secrets in order to make sure you're not exposing the actual usernames and passwords. But the definition is this 8 or 9 elements, which I'll go through very briefly. Some of them are common to NGSI v2, but I'm mainly talking about NGSI-LD here. So yeah, you've got a host and the context broker. Fine, you know which port you're sending stuff to, and you, for the IoT agent, if you want disaster recovery, you just need a MongoDB instance so that you can persist the configuration details somewhere. It is a good practice to include the timestamp and the autocast attributes and set them to true. The timestamp will ensure that there is an observed at property of the property, and that just comes for free, which is obviously required if we're talking about time series information, historical information, and again, that's stuff which we'll be dealing with in part 2. But it means that what you're putting into the system is going to be valid NGSI-LD. And as such, of course, the observed data is just a non-reified element. It's just the UTC string for the time in question. So I said your Mongo host DB port, blah blah blah, is just because we want disaster recovery. You can also use memory, but it's probably better that you want to remember what's going on, and obviously you can then back up the configuration as necessary. The 3 elements at the bottom are unique to NGSI-LD, which is what we're talking about. Obviously, the context broker NGSI version can either be v2, it could be v1, but don't do that, v2 or LD, or it is possible to have mixed as well, which means that you can have a context, an IoT agent which is serving both v2 or a LD or LD endpoints, depending on how you provision the devices itself. So that's an essential. The default is v2. v1 is deprecated, is the process of being removed from all the IoT agents. So I said don't use v1, but yeah, it's either v2 or LD or mixed. And then the 2 elements thereafter, there'll probably a new one coming up fairly soon. At the moment, NGSI-LD supports the NGSI-LD tenant header, and there is a default value which the context broker will, the IoT agent will use for actuation if it's not found as a header, because it's required to have a tenant for the IoT agents. And then finally, you've got this JSON-LD context. That is your context file. Now, this is the one which should be public. Ideally, if you're doing an environment with a high throughput, you put this on a separate instance, at least a separate container at least, because obviously it needs to be accessed on a regular basis if someone hasn't already cached the context file. And that's the one that holds all my common stuff. That's the one that necessarily my own personal stuff, not the common stuff. That's the one which has got the fact that I am dealing with cow collars, I'm dealing with the temperature gauges, I'm dealing with a water sprinkler or whatever. So that's the important part of where that file leads to. Now, when you are sharing this data out to third parties, again, you'll need a copy of that file somewhere on the internet publicly available, so that other users can then read the information in. Right, I actually have a couple of demos coming up, but briefly describe how measures and actuations work. It's pretty much as you'd expect. The device is using a known syntax. Fine, I don't really care what it is. In the demo, we're using something called ultralight, but it's just basically a plain text payload over HTTP. That is then sent to the south port of the IoT agent, which is then checking, hey, am I? Is this a valid message for a start? Is it in the right format? But also interpreting it so that you can transform whatever the format is. It's bytes if it's Sigfox, for example, into something meaningful for a context broker, because obviously you need to have attributes which have got a type and attributes which have got a meaningful name, which align with your JSON-LD context. Having done that, it effectively does an upsert into the context broker, checks that the response is okay, and responds back saying, yes, I'm successfully sending stuff to my context broker. Light probably helps. That's probably a bit better, isn't it? So everything is transformed to NGSI-LD, and it's done automatically. So you don't really need to care once you've got the system set up properly. So the only interface which is required is an upsert, but it could be a linked upsert. It could you could end up with a request which would send update multiple entities. A good example of that is the ISO XML IoT agent, which when you receive an ISO XML message, it's split into multiple entities and it's sent up to do to a context broker. So internally, what this looks like, and this is what this is all done for you, which is rather nice. Internally, you will send a NGSI-LD message, and as you can see, it's relatively long for what it is. But this is, all generated for you, so it's great. It will send the appropriate context. Fine, that's good news. It will attempt to ensure that the ID is a valid URN based on the rules. The URN saying I am a message of an ID for an NGSI-LD format of type device thermometer, and then it will also have the correct type. So obviously every NGSI-LD message needs a type and an ID, and then you have a series of attributes. These may be dynamic attributes, in which case you'll get this observed at in there, or they may be static attributes. Static attributes like controlled asset, for example, is just set up during the provisioning of the device, saying in this particular case, thermometer 1 is in building 1, and it's saying in English, device X in building Y is rated 25 degrees centigrade, because it has got a unit code in there. It's got the proper UN CFAX unit code. Again, this is set up during the provisioning. And in this particular case, you've got additional metadata. You'll notice the unit code is a non-rarefied attribute. And so unit code and observed that are non-rarefied attributes. In other words, they're just a simple string, and they're obviously of a known type, effectively. But something like additional information like accuracy, which is up to you to decide whether it's a property, or it could be a relationship or whatever. Then you have to use the usual syntax of type equals property, value equals whatever. So this is saying we've got a 95% accuracy, and again, the accuracy itself in this particular case could have additional metadata. So this has got the accuracy of unit code C62, which is Unity, which is saying I have a range of 0 to 1. Similarly, let's do some provisioning of groups. If you don't necessarily need to provision every single device individually. And again, when we get to the demo bit, you'll see what happens. Indeed, you can put everything in here. But provisioning groups, if you have an API key, which is a known number or random string, it can be used to say, okay, anything of that particular class of devices is likely to have the following or some of the following attributes. So it's saying, okay, anything in this particular entity type device, the defaults will be it's going to be in the Berlin time zone. It's going to be it's going to have things like a mapping from T, which is the short name, and the payload in this particular case, that will become a temperature in the context broker, and obviously a huge long IRA as far as the rest of the world is concerned. And you can also do transformation of type. So this is saying it's a type float, and you can see there the metadata is well defined. This is saying it's centigrade. You are able to add in additional static as well as dynamic attributes. So the examples in the static attributes in this particular example are all attributes which you would find in the smart data models device. So this is saying, okay, by default, and I can override these, by default, my device is a thermometer, it's a sensor rather than a sensor and actuator, it's controlling temperature, and it's using the ultralight U20 protocol. You'd obviously use such static attributes when you are making queries which are filtering. So you can say, tell me, could you return back all the devices which are measuring temperature? Could you update all the sensors, things like that? So that's why you'd bother putting the static information. When you are defining these types, they should either be property, which is, or relationship, which is by default it's vanilla, but it's possible to put in native JSON types, and then it will also default as a property, but it will do the type conversion as well. Or it's possible to use a GeoJSON type, particularly in NGSI-LD, so that you can define points and polygons and things like that. Should that prove necessary? For individual devices, you might have information which is specific to the device rather than specific to the class of device, or you might have information which is defined in the class of the device and overridden for an individual device. So the device input again can have attributes and static attributes. In this particular case on screen, the temperature attribute has already been defined in the class, the service group, so we don't need to put anything in there. But we've got specific information about device TXHME001XXE, which is obviously something coming from the device itself. And we're saying that particular device is should be considered this URN, and it should also have additional static data. Now you notice there's another bit in green there, link. It is perfectly possible to create an IoT device and say, okay, this device has a controlled asset, and the controlled asset is another entity, and I would want more information. I would want this attribute put onto that entity. So in this particular case, what we have is we are saying that whenever the temperature attribute is updated on the device, also update the building and give it the same temperature attribute with a provided by relationship, saying this particular attribute, the temperature, was provided by device temperature 001. This is how you can get linked data through your relationships. And again, it's all done for you. You just need to put the syntax properly when you are configuring the system. You could have multiple attributes in the array of the link attributes, saying, if temperature or I don't know, soil temperature, air temperature, blah blah blah, are being updated, then all of those come through to a building. This means you can properly map your device as being a device which has got things like battery level and the software operating system and attributes from the device model, and you can leave your thing that it's actually reading as a separate entity. So the usual case I give in smart farming is, I could have a temperature device and it's measuring the temperature of my building. Fine, so they are two different temperature readings, but obviously the building itself doesn't have a battery level. There's more specific stuff which is in device, and indeed, if you look at the smart data models, you'll find that device itself has got a link to another model called device model, which has got things like, where's the documentation of this particular device. So it's even more general than that. GPS. Let's move on to GPS measures. With location payloads, you always have at least a latitude and longitude. And it's a single attribute. Now, the problem is that you can get payloads, particularly with a simple format like ultralight, which can't easily deal with the complexity of having multiple elements to an array. And indeed, you could have the format in multiple different ways. So you could have a string which is a comma separated values, or you could have long and lat as two separate attributes, or you could have a lump of JSON which has got a string or an array of two numbers, or it could actually, in the case of JSON, you could actually properly pass your JSON as GPS. So it is possible to, when you are configuring your IoT agent, to say, look, this attribute is a geo property, or this attribute is a geopolygon, maybe, and it's of type point. And again, the IoT agent will do the heavy lifting for you. If you've got lat long is in a string, it will attempt to make it into a proper geo property, which means you can then do things like your geofencing or georel attribute on your context broker. So when you are provisioning this attribute, an example is GPS, obviously, the provisioning, whether it's on the service group or it's on the device level, is going to be object ID, in other words, what's coming in from the south port, whatever short name it is, and then name, which is whatever it is in the context broker. Slightly different, of course, if you're using a really low-level protocol like Sigfox, where effectively you are saying these bytes go directly here. But this is more usable for the JSON-LD agent, ultralight agent, which is the reason why they tend to get described in the video recordings like this, is you can actually see what it is. Whereas, if you're looking at binary bits, you've got nothing to look at. So anyway, obviously, if you're talking about geographic information, it is very, very highly recommended that you use location, because that is the one default for the positioning of stuff. If you set the type to geopoint on the provisioning, it will assume that whatever is coming in is a point. If you set the type to geo::polygon, it will assume it's a polygon, and so on and so forth. It is necessary to get that right, because if you're pushing in data and you say it's geopolygon and it's actually only just a point, then the upsert will fail in the context broker. You need to put in valid GeoJSON, which is the reason why this configuration needs to happen. It is obviously perfectly possible that you might have a device which sends separate longitude and latitudes, and of course For GeoJSON, it's longitude first. That's again mandated. So there is already a function called expression, which can be used to map multiple attributes to, in this case, it will be a simple string, but because you've set the type to GeoJSON, GeoPoint, Geo whatever, it will end up being a geo property, and the default for the geo property is a point. So this will be a point of longitude and latitude. Now, the disadvantage of using an expression is that this will only fire if both longitude and latitude are available in the measure request. So the assumption is that your device sends lat and long together, because if you only get unless all elements are available, you won't get that to fire. Obviously, everything is geo property. It needs to be valid GeoJSON, so that's all done for you. Basically, if you want to have a takeaway for the first 40 minutes, is that configure things right, and then devices will just magically be able to speak NGSI-LD. Actuations, this is going the other direction. Actuations are based on the NGSI v2 IoT agent paradigm, because it's NGSI-LD actuations are extension of NGSI v2, and that means at the moment this is using the registration endpoint and request forwarding. As I've been mentioning in quite a lot of online materials at the moment, the precise definition of request forwarding is still with the ETSI committee, so it may be the case that the code inside the IoT agent gets updated should the definition become its current definition become invalid for whatever reason. But there are currently two mechanisms anyway. You can use registrations, which is the default because that's what NGSI v2 used, or you can also use subscriptions to do the same syntax. So yeah, once this is finalized, it won't be an issue either way. As you expect, this is basically one of the requirements of the FIWARE, is that you abstract away everything below the context broker. So user sends in something, a patch request to the context broker. Context broker says, hey, this is a device. I'll send that down to my IoT agent. IoT agent says, yeah, this is a ultralight device over HTTP. I will send the appropriate command down to the device. And in the meantime, I'll set the status of that to pending. Now, eventually, obviously, it's quite, because the way HTTP works, it'll come back immediately. But if you're using MQTT or AMPQ or whatever, it will take time. Eventually, the device will say, yeah, I've managed to do whatever you've wanted me to do. And again, the context broker will be updated. So the context broker holds what is believed to be the current status at all times. So this is the way that you would provision devices for a actuation via registration. You can notice that I'm doing this on the device. This has to be done on the device because obviously pushing something down to a real world device to do something is going to be individual to that device. So you can't just say the endpoint is in general. But in this particular example, we have a water sprinkler, and it's got in the device's configuration, it's got a pair of commands on and off. You'll see this in the demo in 20 minutes. Effectively, what this is doing is it is setting up a entity called where's the thing? Yeah, URN NGSI-LD device water 001, and it is then adding a registration, a CSource registrations, to that same entity. You can see on both sides that we are using the, well, on the configuration, we use the old FIWARE service header, which is because this is backward compatible to NGSI v2. But within the context broker, LD context broker, it becomes an NGSI-LD tenant. It automatically uses the appropriate at context, and it is saying, okay, the following two properties, on and off, are being held by me, the IoT agent endpoint. So whenever something needs to change there, you context broker, need to tell me, IoT agent, that you need to get something done. Now, the bidirectional attribute works in the opposite way, in that instead of the IoT agent being responsible for the attribute, the context broker is responsible for the attribute, but it sends a notification of a subscription down to the device. So it's again, you would, in this particular case, we are setting up a bell, and the bell itself has got an attribute called ring, which is of type text. It's a string of some sort. It's one of the default ones, property, but that is an expression which could also have a reverse, because it's bidirectional. Either it can be read to the context broker, or it can be removed from the context broker. And internally, what happens is that there is a subscription set up saying, okay, context broker, I'd like to know whenever the ring attribute changes. And of course, a subscription is sent, and then that will cause a cascade of events going down to the device itself to do what is necessary. So yeah, two options here. At the moment, the default is the registration way of doing it. And as you would expect, it's the more popular way of doing it. It works with Orion LD, but you do have this alternative if the context broker you're using doesn't support the same forwarding mechanisms at the moment. Right. Okay, I'm going to stop there, and I will. I'd like to move on to a little demonstration. So I haven't got access to the videos, so is Kia around to try and do some of my video? Where's she gone? There she is. She's back again.
Bring up the name of this big one.
Where IoT agent .mov.
Let me play this. Okay, I need to unshare. Remove your screen first.
Okay, so this is a live running example, and you can see that I've configured my various elements within my Docker Compose. Those various things like the context, and you can see I'm already running an IoT agent. It's responding on a particular endpoint. Now I can configure the service by having as many attributes as I want. In this case, I've got they're not necessarily all going to be at every single device, but this is saying, you know, if it's BPM, it's going to be heart rate. If it's temperature, it's going to be T. It's whatever. And you can see that I can do multiple elements in there, as well as unit code and Celsius and what have you. Now, if I just send a device measure now, having done that, it would be sending in the format, in this case T3, and as you'd expect, the context broker would then pick this up. So when I look in the context broker for that particular tenant, we can send this, and we can see that it has already sent the attribute, and you can see from the GET request, it's a NGSI-LD GET request with the appropriate metadata. Now, we also can do this command under this water sprinkler command, and you can see again it's provisioned with the commands on and off. And once again, you can see I've now got my little dummy thing there. At the moment, the water sprinkler is off. You can see that just refreshed it as being off. And then if we go into the a patch request, which is the way you do it, it's sending X. It doesn't even matter. It's in fact being updated. And if I send that, you can see that the water sprinkler is now on. It's changed colour. If I was doing this live, you'd hear a nice little water sprinklery sound as well. And it's pushing information through. Similarly, I can send an off attribute. Whenever you send the same thing, it will repeat the action. And again, the water sprinkler has now been switched off. So that was my first of my little videos. So for now, I need to go back to my presentation. So I need to share again. Is that right?
Yes, sadly it is.
Okay, so it doesn't really make much difference then whether I do it from my machine or I do it from your machine, because again the same thing would happen. I'll get kicked out to the beginning again. I was trying to be clever. That's what it was. Right. So on that one, actuations. Okay. Let's see what we're doing. That's where the one that. So imagine you want to get data into your system. You could extend into your NGSI-LD system. You could extend the concept of IoT agent in multiple ways. You could, for example, create your own IoT agent, which would listen to a port for upload of, say, CSV files. And indeed, there's a tutorial which I gave on how to do that in the link on screen. And that would mean that you can receive an event with some sort of data, or the option of being able to retrieve some sort of data. And then at that point, you need to do this upsert function. In the case of this simple CSV file, the processing is custom. It's saying, okay, the format of my input is my own format. And therefore, I take this attribute, I put it there. I take this attribute, I put it there, and then it just ends up doing a simple upsert. You could just as easily do something like, and I use this in the another example as well. You could use a database as an intermediary. So you might want to have your random third-party system. It's a MongoDB database. Push some stuff to a database. At some point, you regularly poll this database to receive information, and can then create the necessary NGSI calls. You've got to work out at what point in your particular system are you moving from using the actual device, or using the actual stuff in the real world, or using a implementation of the thing in the real world, into I am now moving into the context domain. And you obviously don't need to send literally everything to your context broker. It's just the bits which are relevant. And the example of this upsert I've got on screen is I'm just pushing the ID and the building name. That could then become the context of my system. I'm not necessarily looking at saying everything is context data, or indeed everything reaches context data, but the concept of a context provider in NGSI-LD, strictly speaking, is anything which can do the upsert, because it's informing me of something informing the context broker of something out there in the real world. So you can think that whatever my third-party system, my legacy system is, I just attach something to say, oh, and I'll tell the context broker that this has happened. The idea of registration, NGSI v2, and therefore it's part of the possibility for NGSI-LD, because it's the extension, is that it is possible to abstract out this additional functionality. So if I have a registration, as I did with the IoT agent, I'm saying either tell me about X or I want to update X, and I'm responsible. Now, this is nicely decoupling the additional stuff, the augmented context, from the context broker. Context broker will never deal with some random weather API from some third-party service which needs to be logged in, security, what have you. That would then become your custom code to do the necessary so that you can get the information. But what you can do is you can create a registration to say, okay, as far as I'm concerned, the tweets attribute in this case is registered from an endpoint called my legacy system. And then my legacy system needs to listen on the equivalent of the patch request, but you know what that format is going to be, and you can use things like regex star whatever in your little web app to actually listen in to get the ID and the payload. The payload will be of a known structure, because obviously if I'm listening in on the star/attrs/tweets ID/attrs/attribute, where ID and attribute are placeholders. I know that if I receive something on that endpoint, it will be dealing with the attributes for building 1 eventually, and it will be getting the tweet system. At that point, you write your code to say, okay, I'll go off and get my stuff from a third-party service, or I push my values into my third-party service, and it will alter the values necessary. This example here is saying, okay, I'm going to push a tweet onto the onto Twitter, let's say, but it could just easily be used for saying, okay, I want to get my weather forecast, I want to get information from my third-party system or whatever. And looking at the pseudocode at the bottom, it's more along the lines of, okay, now that the service I've written, web service I've written with a little bit of glue, has received the function to say, now, and I get this is NGSI-LD, it will go off and do something, do what's necessary, and then return with a payload in the format of NGSI-LD. An example of this can be found within the FIWARE tutorials. So it's very simple. You can just muck around with the code as necessary. The idea being that you've got a breakpoint here. You need to have something which can allow you to change your code in whichever custom manner possibly. So do something is deliberately vague so that you can actually go off and do whatever's necessary to add that additional legacy system into the slide deck. You could see the example I was giving yesterday with the veterinary practice. I wanted to get vets records. Again, you may need to have some sort of negotiation in order to do that. But what would happen is I would get the vet's records for cow 1, and I would then update cow 1 as part of my do whatever I want to do before sending my response back to the context broker saying, yes, successful, I've managed to do what's necessary. Extending legacy systems via subscription, inform me so I can do something. This actually forms a lot of the second half of this presentation as well. Subscriptions are remarkably useful in that it's telling me that something has happened, and it's also supplying me in the data attribute with sufficient information that I can actually deal with it. Now, the example here is quite simple, is that it's just gives you the ID and type and one attribute. But you could give multiple attributes. You could give, say, a relationship as one of those attributes, which would obviously come as a object rather than a value, and then the code, the processing code at the far end could say, I want to go off and do something with this. So again, pseudocode on the right hand side is just saying, okay, I've received a data element within the body of the subscription. Obviously every subscription has got a data element, and then it's iterating through the entities which have been returned, saying I now need to go off and do something with each bell that's doing something. So it's another mechanism for me doing, say, I don't know, sending an email or whatever because something has changed. Once again, you need to return the appropriate status code 204, which is successful and no response, as each subscription is monitored as part of how it works, and as such, each subscription should return a 204. If it doesn't, the statistics will say, yeah, and I failed, and I failed, and I failed, and I failed. So that's necessary. Again, for both registration and subscription, there are effectively rules as to how you should process these. And returning 204 successfully is obviously the only requirement for a subscription. Obviously, it doesn't need to be 204 if it's not successful, but for the registration, it will depend on which forwarded endpoint you're talking about. So for a patch, for example, it's just going to give you a response, but for a get, it may well need to return the attribute in an appropriate NGSI format. Easiest way to check what the format should be would be to make the same request on a broker with some dummy data and an attribute in it before you even test it, because whatever there is no difference between a request and a forwarded request. as far as endpoints are concerned. There is actually one very minor difference in that whenever a request gets forwarded, it gets a new forwarded by header. This is to stop loops, because you could imagine a situation where I have a context broker 1 has a registration, and it sends information to context broker 2, which sends information down to context broker 3, which then the registration is back to context broker 1. So you've got a circular dependency, and this forwarded by header, just you can check that to make sure, oh, am I already in this list? If I am, then I can't respond to this because it's somebody else's problem. But beyond that one header, it should be the case that your request is the same as if you were doing it directly a context broker. Actually, come to think, no, I'm not quite saying the truth, because there are certain headers which are unsafe headers, and the unsafe HTTP headers obviously wouldn't be completely duplicated either. So if you've got things like content size, for example, it follows the standard HTTP rules. So if it changes between the various different systems, that would obviously be different as well. Yeah, so the subscription. So we're coming towards the close of part 1. As usual, I want to leave you with a series of useful links. I hope I've emphasised that for NGSI-LD, you need to have a proper background understanding of JSON-LD, in that it's not for me to fully explain what JSON-LD is or what the app context is in terms of JSON-LD. The guys in the JSON-LD videos do a better job of describing their part of the API than I do. So it's worthwhile looking at their documentation and their presentations as well. As NGSI-LD evolves, it will evolve in line with changes to JSON-LD. So, for example, things like the language attribute is a basic part of NGSI JSON-LD, and therefore it will be part of NGSI-LD becomes language property later on. Obviously, you find the latest ETSI specification, and you must have your proper models for whatever you're dealing with. So that is going to be the end of part 1. I suggest we can take a 10-minute break to give me a chance to actually get my breath. And then we can come back for part 2. Start off by going through the Q&A, and then I'll move on with the rest of it. So I will see you again in about 10 minutes.
Okay.
Right, I hope you had enough time to grab yourself a cup of coffee. I know I did. I was going to look at the Q&A tab now to find out what I didn't explain properly. In the case of measurement, okay, so the guy Dylan's got a question for me. In the case for measurement sources having files that are stored on, e.g. an FTP server, does it make sense using an IT agent for these measurements, or is it better approach directly posting to the context server? That's an interesting question. Like most of the answers, the answer here will be it depends. Now, context brokers only hold the current value, and they only hold usually a string, a number, some sort of JSON primitive for the attributes. So the actual file itself is not going to be part of the context data. it is possible you could have a link to the FTP server, for example, which could be saying, and you can get more detail from the file here. If you are reading data inside that that file, and you've got something which is retrieving the file by FTP, if you could get that to do an upsert, I believe that would probably be better. But actually, what I'd quite like to do, because you can do this on the AirMeet, is that would it be possible for Guy to raise his hand and come back up on the stage? So could you try doing that using the raised hand functionality here?
Yes, everyone can do that.
So if we want to try and get a Guy to come up on stage and describe his issue in more detail.
Just simply click to the raise hand function in front of you on the screen, and then I will bring you on the stage.
Or if you're having difficulty, just send something in the chat and we'll try and work it out. But Guy, I can see you're in the list of people who are online. So unless you've still got the you can go off for your cup of tea, we can actually try and get some more information. Or indeed, if there's in the meantime, if there's someone else who's got other questions from the first session, we can put that in first and then try getting Guy later. Or are we going to have to move this to the end? I think since we're not getting a response, and rather than just sit for an empty screen for the moment, we're probably going to try that again later. In the meantime,
I think we have someone. Okay.
Has he?
Hello.
Brilliant.
Can you hear me?
Yes, we can. This is the whole point about these complicated systems, is that you can probably describe your issue in more detail and better than I can actually describe from your comments. So, do you want to elaborate what your issue is and what how you would propose to solve the problem?
Yes, sure, no problem. So actually, my question is about you see today still a lot of sensor devices sending let's say measurements in batch to in a file to an FTP server. So the devices store internally on the microcontroller their measurements. So eventually every 1 minute they take a measurement, they buffer these measurements and send once in a while, every 1 hour, every 3 hours, these measurements file-based to an FTP server. So my question is actually how to get these messages inside the context broker. So that my question was, or what I'm already doing right now, making a kind of agent or a script that reads these files on a regular basis, processes the individual measurements in the file and post them to the context broker. Or, that's my question, would it be better to develop a kind of IoT agent that will do in fact the same, but instead of pushing or publishing them directly to the context broker?
Well, there are various different techniques you can use here. This is why it's such a complex question. This is why I wanted you up on stage anyway, so you can give more details as necessary. Now, again, in one of the FIWARE Wednesday webinars, I described an example about how you could read files and use an upsert. Now, that was a little custom component which I created, but you could see that you could extend this to actually do an upsert using using the IT agent node lib. The IT agent node lib is all of the common stuff that you need for interacting with an IT agent. For a simple one-off file upsert, you don't need that level of complexity, because if all you're doing is one upsert, then your own custom component saying, okay, I just need to do an upsert like this, job done, is sufficient. However, the advantage of using the node lib, if it's relevant and it's stuff which you want to maintain and continue using in the future, is that obviously the library gets updated on a regular basis. You know, there might be a new security function, there'll be bug fixes, there might be a new version of NGSI, because obviously NGSI-LD came in for free onto top of the NGSI v2 stuff, for example. So it would be a function which you'd be able to leverage bug fixes if it's relevant. However, that being said, for the system you have described, I think that it's probably not relevant because, for a start, the format of your files is probably proprietary, so it's probably not a generic solution. Correct me if I'm wrong.
More or less, it's not proprietary in that sense. That's in the domain where the sensors are active. It's let's say a general used format. It's
well, that's slightly different. Okay, if you're within a domain which is useful, it might be worthwhile considering if it's a component which could be of more general use and therefore using the IoT agent, or IoT agent node lib, or there is another library called NGSI-JS, which is obviously the name suspects a JavaScript library, which can do just NGSI functions. So it doesn't do all this device provisioning, mapping attribute X to attribute Y, mapping ID external to ID in the context broker. It just says, okay, I will offer you at the moment it's 27 functions of NGSI. That again is within the FIWARE catalog, and again that will be maintained. So if, for example, 6 years down the line there's a new version of NGSI, or there's new functions on NGSI, that library will be expanded to cover the additional stuff. So you don't necessarily want to do everything from scratch. The advantage of just coming with a point solution is it's quick, it works for me, fine, not a problem. If we're thinking about, is this something worthwhile in a domain, then you might want to start looking to see what helper functions are out there. My thought at the moment, for what I understand of your situation, is that you are probably best off with the solution you've currently got, which is an ad hoc solution, at least in the testing initial implementation phase. And you might want to look at seeing whether the NGSI-JS library is the one for you. I don't think you're looking at a full IoT agent because you don't need the mapping functions.
Okay, thank you.
Okay, I don't know how we get you off the stage again. That's probably key. Yeah, fine. Kick you out and put someone else on. Any more questions for that? Because it's rather interesting. It's much better to get in a position where you can advise or help people as necessary. I mentioned on my the previous session that I'm available on LinkedIn. Just look at Jason Fox FIWARE, you'll be fine. So if you find out that you've got an issue 3 weeks down the line, you should be easy enough to get hold of me. Problem about talking for 2 or 3 hours on end is that you do need coffee. Okay, let's kick off part two. Part two, processing of historical information. You're going to find that this starts getting a little bit repetitive because FIWARE is not that complex. You can probably work out that we're going to be reusing some of the concepts from the previous slides. I'm not talking about stuff orthogonal to FIWARE like a security, which could be completely different. I'm talking about the functions. And the functions, as you know, are basic CRUD, registrations, and subscriptions. And for processing of historical information, in the main, we're talking about subscriptions. Something's happened, I need to log it. And we can do that in a variety of different ways. Okay, so data persistence, hello world. Easiest way to do this, and this is effectively the opposite of the sort of use case that Guy came up with, is that I have something happening in my context broker. I want to put it to a database. Now, before you start on going down this line, you should be aware that there is an optional, I repeat, optional temporal interface, which could be persisting your data in a manner which you need, which you could need anyway. But that obviously leads to different problems rather than the way it is, because if you are using offering the temporal interface, all your data will be stored in the temporal interface, which is going to be a large data requirement. If you're looking at logging a certain amount of events, or you're looking at doing various things with, say, a limited set of attributes or a limited set of entities, then you are probably not going to need the full temporal interface. You can get away with just having a small microservice to do data persistence. Traditionally, context brokers don't have a memory, which is why temporal interface is optional. And the idea behind all of the components I'm going to be showing for the rest of the afternoon is that you can swap them in, you can swap them out, you can decide, okay, I want to put it to this sort of database. Maybe one of them can do one sort of persistence, and another one can do another one. So you need to pick and choose, or indeed you can, as we're going to, as I'm describing to begin with, you can do something yourself. And I'm starting with a simple example of doing stuff myself, because this is effectively what all the other ones are doing. They are reading in the incoming data coming from a notification, a subscription, and then doing something with that data. The example I gave in a video was where I wanted to get a list of street names, so I could do a workaround to get the ordering in say Swedish, let's say, where they've got the A and the O the wrong way. It's a natural language collation issue. I did describe another mechanism of doing that, but hey, in the case where I've got a small problem, it's better done in a database. I've got limited data. Let's just throw some of this information into a database using a one-off subscription. Now, this is a very simple subscription saying I want to get all my building entities, and if you're using NGSI v2, when you do a subscription, it will, at the moment, fire automatically with the data that's currently got, which could be quite a large data set. They're adding in a new flag to make it the default the other way around, so that it'll only hold the information afterwards. But what you could do is you could put in a subscription with a nice broad application, so that your data will get in there beforehand. Obviously, you could filter this. I've filtered this by entities, but you could actually get a type pattern or an ID pattern there, and you can add in which attributes, watched attributes, are sent, or you could add in a queue parameter. But the queue parameter is probably a good way of ensuring that your data isn't updated too frequently if you want to narrow down that, only things which have changed since or whatever, so you can get a certain amount of values. Now, for a NGSI-LD subscription, obviously you will have the at context, and that at context will be passed through on the notification, and this will mean that your long names will come through as you would expect. So what we get from any subscription is I haven't got the subscription on there. Okay, fine. Is an array which has got the data in there, and this is just the world's simplest data persistence function. I've written it in Node.js because it's relatively easy to understand. I have something. It is listening on an endpoint. The endpoint which I'm exposing called duplicate buildings because I'm pushing it to a database, and then it just does a for each on each element of the data that goes in, does something. In this case, persist to MongoDB using a MongoDB library, nothing special. Upsert, fine. The upsert function just sets the appropriate syntax for the transaction, and then does it, and it's just done through a promise. I mean, this is so simple to get data persistence. You would think that, okay, why wouldn't I use this for all systems? Well, it has its drawbacks. The advantage, of course, is a simple solution, but I have to write the syntax for persisting this. It can do something for me. I need to do something done quickly, but, and this goes back to the discussion we had, the Q&A, it is proprietary to me. If you can find tools out there which can do the job, and indeed we've got, I think it's now 5 software components within the core context area of the FIWARE catalog, which deal with the different forms of data persistence. It will be better to investigate the other solutions, because all of these data persistence components, apart from the temporal endpoint, are using subscriptions. Because subscriptions are in a well-defined format and well known for each system, you can easily swap one out and put another one in. If you find that, I don't want to be using MySQL anymore, I'll be using CrateDB. It's also going to be necessary to effectively run your own beauty contest to work out, okay, well, maybe NiFi is taking more memory than I'm prepared to take, or it's faster than Flume or whatever. There are multiple ways you can do your persistence. There are multiple elements in the catalog, and each one has its own reason for being, but you need to check out, does it actually work in my use case? Don't just pick the first one on the list because it's one at the top of the list. They all have a good reason for being there. Now, the obvious disadvantage of my simple little web service is that it's not going to scale. It's when you're talking about smart systems, you're probably looking at systems which you are going to be under stress, and you want to be working these at scale. And obviously, when you have components of the FIWARE catalog, they tend to be also in the Helm charts, which are being created around each component, which then means that it will scale automatically. It will shut down if it's unhealthy, and so on and so forth. But perhaps the most important part here is if it's my solution, the bugs are my problem, and I need to fix it. So the advantage of using an existing component is that you will find that they are actually in continuous development. Each FIWARE component has got a file in the, I think it's the docs folder, called roadmap, which will say what's coming next. So it may be the case that if what you're after is not in there today, it might be in there in 6 months, or it might be it might stop you having to worry about your point solution if there is the option that just hold on for a little bit. We're putting this in already. Of course, all this is open source. So if you have a component which is doing multiple databases, but not the one you're after, well, by all means, you can create a pull request in the right format to cover that as well. Well, here's an example. This is one of the newest components which has been added into the FIWARE catalog. It's called Canis Major. There is a specific component for persisting into distributed ledgers, blockchains, that sort of thing. Now, what we're talking about here typically is a transaction where you have the subscription which is saying an event has occurred, and you want an event that is traceable and can't be spoofed. So this is the reason why whenever you push data in through this subscription, it will persist to your blockchain and you can never delete it. There is, of course, both pros and cons to a system such as this. The obvious disadvantage is that you can never delete it. So you can't put in information under GDPR, for example, because there must be the right to forget. However, there are other domains where having a log of what will actually happen is really, what actually happened is really a legal requirement, and therefore it is actually a pro rather than the con that you can never delete this. It's a matter of using the right tool for the right job. It is also possible using these blockchain components to have a secured update across multiple brokers, because obviously a broker could push something to some sort of distributed ledger, like the IOTA Tangle, or it could then be received somewhere else on the globe, which is talking to the same blockchain. We know, because the mathematics will tell us this, that the system has updated and settled, and because it is now certain that the changes occurred, then a separate broker could actually update the same value. So this is a mechanism for getting hold of the data in a unchangeable manner. However, the majority of data persistence systems are more likely to be based on your traditional databases, and are likely to be editable, deletable, updatable, maintainable, blah, 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 which is obviously something which is much more useful for the vast majority of systems. I'm going to show a short visual example with one of our systems. I'm going to show you Quantum Leap working with NGSI-LD. I think I mentioned this yesterday, is that at the moment the subscription interface for Quantum Leap is reading the subscription date rather than the modified observed at date. But I believe that the upcoming release is, I'm not sure if it's offering the hierarchy or deciding that observed that is better than modified at is better than the subscription date. But you can see there is a theme here in that what you need to do is you need to raise a subscription, in this case an NGSI-LD subscription. Quantum Leap will interpret the payload properly, and it will push it to a database. Now, the preferred database for Quantum Leap is CrateDB, and we can also, because that is a well-known interface, it's got the same syntax as Postgres, I think. You can also put stuff nicely up on screen to show what's happening. So I will now endeavour to bring up another little video, and I'll try doing it myself. So I'll come off that, and I will put on Quantum Leap. Now we'll then present to audience, select share screen, Windows, Quantum Leap. As I said, the reason why I end up doing it this way is because AirMeet does tend to take far too much memory if I'm trying to run this on my machine as we go along. So it's easier just to show you a little video I prepared earlier, which is under no stress from my my PC. So again, you've probably seen this already. This is my little smart farm demonstration, and I start off by starting the devices by getting them to come out with some data coming out, so you can see that the filling station is doing stuff and what have you. At this point, I can create a subscription. You can see the subscription here is for my feedstock. It's looking at the filling level sensor. Now, if you have a look at the NGSI-context JSON-LD file, you'll find that expands to a URI which is already in the an IRI which is already in the system, and you can see the format of the attributes is normalized, so it's going to be full NGSI-LD, and it's just looking at the filling and the location. Now, the location means that we'll be able to show this particular value on a map at the end with a bit of Grafana. Filling level station, you can see it's only these attributes. It's a limited amount of things I'm putting in through the system. As it is, I've just get a nice little created. I can also say, give me all the animal devices, so type device, it'll give you all their information. However, it is possible using subscriptions to reduce the amount of data coming in, because I only want to get it periodically. So this will be once every 10 seconds, for example. Again, we'd send it, again, it would do a created. Now, you'd wait for a little while before checking the subscriptions to see whether you can get whether it's actually doing anything. And you can see you've got the details of the subscription I created previously. If I scroll down, you can find out that this one has now been sent. Time sent and last notification, which is, you can now see it on the screen because I've got the thing on there. Last notification is giving you a timestamp as to when it last fired, so you can see whether something is firing or not. And indeed, when I was making a record of the video, I found out I was doing something wrong because I was calling it filling a sensor rather than filling level sensor. So this is the first place to look when you're debugging and seeing whether it's working or not. And again, we've got another, the two of these, both of them are putting data into our system. So I just make sure I've got some data in for that filling station by removing some hay from my barn. You see the number will slowly go down, 84, 92, 84. This is so I know I've got a certain amount of information there. Obviously, this is going to be one of those slow notifications. Therefore, I can accept every single entry. And obviously the data persistence components tend not to be terribly visual on themselves. So we're just going to try querying things to see what's happening. It's going to give me a time sent. It would, if I can get. Damn, it has updated. Now you can query Quantum Leap directly. If I pause that, is it going to come there? No, it's not good. Oh, I didn't do that. Wrong one. I'll play that again. Yeah, so it's now got to be sent 4 times rather than once, because I've sent the information in there beforehand. So you can get the version information. I'm using version 8.1. You can use that for a heartbeat as well. And we can now start doing a few functions directly on the Quantum Leap API. Now, this is the difference between your temporal interface and other components. There are currently two short-term history components. Quantum Leap is one of them. SCH Comet is the other. And both of them have got very similar functionality to the temporal interface. However, the temporal interface has got the backing of ETSI to say this is how requests will need to be done. So this will potentially not be aligning 100% with the definition of the temporal interface. So typical for temporal interface, it'd be /temporal/entities/ something. And you can see on the top of the screen, it's saying /v2/entities, blah, blah, blah. But obviously, this is a relatively limited API, so it's not that difficult. It should be quite obvious from what you're reading here that you've got a looking at the attribute, particular attribute, the filling attrs, the filling level, which is expanded to that long URL, which becomes whatever it is, and we are looking for the last three values. And if I move down there we go. Come on, let's be on the screen. You can see. I should move this up the screen next time I do something like this. You can see that you get a timestamp, and you get the values from that timestamp. In my experience, this is slightly quicker than using the temporal interface from Mintaka at the moment, because it doesn't do the full at context functions or the pagination type things in quite such a same way, but it's the same basic idea. Effectively, it's querying a database behind the scenes. If I get the last two rather than the first two, you can see that because I only had 5 entries, there's only 2 entries left. Now you can do the latest ones that will give 75, 74. So you can see it's slowly going down. And of course, there are various aggregate functions. So for example, if you want to sum, why you'd want to do this, I don't know. But if you want to sum what's the last 3 values over a minute, over the most recent minute, it will tell you what the time of that minute is. And it will give you the value there afterwards. If it had been running over multiple minutes, you get more than one value in the array, obviously, saying it was doing over this minute, over that minute, over this minute. But you can see that you are getting a number of time-based functions quite easily without any necessary changes. You can, of course, do things like maximum and minimum values, 171, and maximum, I think, was probably 96, I'm not sure. Maximum was 84. Okay, so the reason why it's not 96 is because I'd done this beforehand. And we can also try doing things like within an area. If there's nothing within the area, it will return a blank. If, however, there is something within the area, so this is near to the point, it's doing a geoquery here. You can see that it's got the values for coming in. Now that's interesting. If you have a look, this is looking for the device attribute. So the device entity, not device attribute, and it's looking for the heart rate of the device. So this is the equivalent of the temporal interface with the Q parameter. We're saying, okay, give me heart rate near to point X, Y, Z, and it says, okay, I've got two entries for this particular pig, getting close to that point, or alternatively, as they move away, they're not going to get a value because they're wandering around as necessary. The underlying database behind Quantum Leap is Crate, and Crate itself offers an API to make direct SQL calls, so you can do stuff directly on SQL to get information. Generally, if there's already an API function, you should use the API function because that will obviously get the syntax perfectly correct. And indeed, I think I come with a nice error message later on in a bit. This is telling me what the various different databases are. And I can find out what tables I've got. Now, when I look at the tables, you can have a look. You can see that there is one called ET filling level sensor, ET being for the type of the entity, and ET device for the devices. Because I've raised two separate subscriptions, I've got these two separate rows in the tables, one for each one. You can see that those are the only two I've got. The other one which you've got in there is just a default. That's right. I think that's right. Metadata information, not default. So you can also do a requery of certain things. So you can now, as you can see, and I'll show this more graphically later, you can actually make direct database queries. So that should be a fairly obvious SQL statement to everybody, saying, yes, I want to get for the tenant, NGSI-LD tenant, MT is for tenant, OpenIoT, ET filling station for that device. Give me everything for device 1, which is the only one which I actually bothered moving some hay out of the barn, and it should. This is where I got the mistake in the naming of it. It should be filling level sensor, not filling sensor. But again, this is useful if you're looking at what statements you could make there, because obviously the reason for showing you a mistake like that is to ensure that you've got understanding of how to debug this damn thing, because when it doesn't work, it's worthwhile using the SQL endpoint to find out, well, what am I doing wrong? You'll find in my next little video that there's that I'm trying to retrieve these values, and of course I need to get the names of the various values correct as well. And again, we can do this for a motion sensor or whatever if necessary. Right. Stop sharing that one. Now, one of the reasons for doing the this data persistence stuff is that you want to be able to get it out and display it somehow. Depending on the system you're after, you could want to use, say, something like, I don't know, knowledge to get hold of stuff from a MySQL database to make some sort of data analytics or whatever. There's all sorts of things you can do. But the important thing is that once you have left the context world, in other words, the right now, and you've pushed into a database and you've got some historical stuff in there as well, then it's a matter of get rid of that one. There we go. Which one? No, I don't need that one either. That's the one I'm after. It's a matter of using the appropriate tool for taking your data, manipulating, putting it on screen, seeing what actually works. So taking the filling station example, we've now moved away from core FIWARE to third-party components. I don't really mind how you visualize your stuff. It's whatever's going to make sense for you. This is just an example using Grafana to try and get information coming out. So we need to choose a visualization. We could have a graph if we wanted to, but I'm just going to put a little marker on the map. Again, these are standard components, widgets in Grafana. You know, this is all the stuff you can get down download this for free. I'm going to place a map nicely where my farm is based, which is obviously in the middle of Berlin, and I can just paste in the latitude and longitude. The basic viewpoint of a map will come up fairly soon, I think it is, but it's just setting up the various values so that when I eventually put some data on, we'll be able to see what's going on. Now, this is just the way you would actually connect to your CrateDB. I've already configured this properly. I'm not trying to say use Crate, use Grafana. I'm just trying to explain how you could, once you've got the tool of your choice, and it's now this is where you need to put the right names of the fields in. The time column for Quantum Leap is always time index. That's one thing which is worthwhile putting in. You can put the fact that we've got the following entity up, entity OD here, which needs to be edited. You can see it very kindly tells me that this is not correct. And then we can say we could correct this to entity ID, as it should be. And we're now starting to get a map. You can see the map is now looking at somewhere in the middle of Berlin. And we're going to, we need to put in the value and the, for the various field value and location. Obviously, some of these names have got specific meanings for Grafana, for example. So we're going to put a marker on the map. And to do that, you need to have something which is GeoJSON. Because again, it's nicely warning me about what the various problems are, which is obviously very useful. And I can put an entity type in there as well. So it would be possible to put my animals on the map just as easily as it is to put my thing. And this is just a table of data. And it should be the case that when I now go into the visualization, I've got a new map layer, which I can put in there, the feeling level sensor map layer. And if I set the icon for this particular thing to something which will visualize, I think I put an asterisk. You've got lots and lots of icons you can use. And then we just pick something, asterisk. And I've got something up on screen. You can see that I've got I'm reading stuff from my database. And I can do things like averages or thresholds or whatever, which are obviously when I've only got the one entry, it doesn't make much sense. But you can see that these will change color because it's within a various range of stuff. And you can see there's information coming through on my from my database. So this is the whole point about the data persistence. You persist the data because you want to get the information out, and you don't want to necessarily have the now. You can get a historical graph of where things were. That's a good example. Or you could store the data so that you can do additional information. You could, of course, do logging as well. Go back at slide 1 again. I've got to find out how to avoid doing this if I'm going to be doing live stuff on a regular basis. Okay, was that one? Yeah. So that was a brief. I'll move that back over here so I can look at the screen. So that was a brief example of how this would work with Quantum Leap. All the other components are very similar, but they specific about Quantum Leap is, firstly, it is time series, and secondly, it is only crate DB. So if that's not the database you need, or maybe you want to put to HFDS, or you want to put throw it to CCAN, or you want to put it to MySQL, or you want to put MongoDB, or what have you, you've got the wrong component. You need to work out which one will work for you. Now, on generic data persistence, there are two main options. One is Cygnus, and the other one is Draco. Now, both of these have got two flavors. There's Cygnus and Cygnus-LD, and there's Draco and Draco-LD. And they do the same thing. It's just that one of them is listening deliberately for the V2 endpoint, and the other one is deliberately listening for the LD endpoint. Now, the LD versions are more immature than the V2 ones, obviously, because V2's been around longer. So there are some endpoints which would not be currently supported by Cygnus-LD or Draco-LD, but that's not actually a big problem, because if you remember, when you raise a subscription and you're using Orion-LD, it is possible to use the X-NGSI v2-normalized key values or compacted formats. So you can trick Cygnus into thinking it's communicating with a V2 context broker, and therefore it will persist data properly as you would expect. Now, the difference between Draco and Cygnus is quite simple. They are both doing precisely the same job. One of them is based on Apache Flume, and the other one is based on Apache NiFi. NiFi is more visual, whereas Apache Flume is more based on configuration files. And it really doesn't matter which one you use. I find that Cygnus is usually faster to start up, which is the reason why that's going to be my demo, but I'm not going to demo both of them because they do the same job. At the moment, there are about 10 syncs. I think that list is up to date, but you can see you've got things like CCAN, DynamoDB, HDFS, and your standard databases like MySQL or Postgres or whatever. It is also possible for Cygnus to actually push back to Orion, so that's doable as well. Similar to Quantum Leap, you've got the every component has got full documentation. FIWARE Cygnus Read the Docs is where you'll find stuff on Cygnus. You are able with both Cygnus and Draco to be able to deal with multiple syncs as well. So the first diagram is just saying, okay, I just want to push stuff into a MongoDB database, which is how you would get historical data without expanding your system terribly large. But you've got to remember that your context broker is usually not sharing a database instance with your Cygnus. It would be a separate location. The only reason why it's done that particular way in the diagram is because this was a simple little tutorial and it's trying to minimize the number of components. A more realistic scenario is where you've got this, you're raising your subscription on, in the case of Cygnus, a well-known port for each database type, and then it is persisting to its own MongoDB, its own MySQL, its own CCAN, because that way you are decoupling context broker from other parts in the core context. You can potentially scale each element differently. You are able to persist your database, or back up your database, or destroy your database, or deal with disaster recovery in a more convenient fashion. It is obviously, Orion has got a MongoDB instance because it needs to be able to remember things like the context which has been run, or the fact that it's got a registration for some third-party source or what have you. Now, if it didn't have some sort of memory database attached to it, if Orion had a fault and it went down, when it came back up again, it would have no entities or no way of recovering those entities. But in general, you'd expect that the Cygnus component would push stuff to a completely different location, and it would push stuff to whichever database you want, and then you are responsible. You are responsible for cleaning this up. You are responsible for making sure that you don't run out of memory. It's all your business outside of the context layer. The context layer effectively ends where Cygnus is receiving the stuff from the database, because that way you can pull it out, you can put something else in, you can put so it's got the flexibility to do the various persistence information. So I'll briefly show you Cygnus. I won't show you Draco because it's the same demo basically, but let's briefly have a look to see how Cygnus works. Okay, so this will be the Docker Compose for. Let's check that actually got that right. Yes, yeah, I've got that with it over there. So this is the Docker Compose for Cygnus. All the components can run on bare metal, but it's more a case of you'd usually containerize these. And as you can see, I'm exposing a couple of ports. Default for the MySQL port is 5050, and that is where you would send your subscription. I've put in a bit of configuration here so that I can get hold of the various information, like what's my password, what's my username. What I've done here, of course, is massively insecure, and you should probably be using Docker secrets. Docker secrets are supported. If you put _file at the name of the attribute, then it will have a path to a file which will then hold the secret. The secret. It's fully described in the documentation. So don't just put root and 1, 2, 3, because obviously that's my. These are just the defaults. This is just the tutorial, and you can see that I can configure different locations for the defaults as necessary. Again, as I keep stressing, you could actually just set this up directly through the config and either add that directly as a volume, or potentially create your own image which has got your changes in it. So yeah, I've got my devices. I'm just putting a lamp and some doors and stuff like that. Now, this particular version, I'm using the NGSI V2 endpoint. But as I said, I can use the legacy to do something else. The X NGSI V2 legacy endpoint. Once again, we're just going to see, is it out there? There's a heartbeat for all of these. Yes, I've got version 2.10, which is relatively old. And then I can do a subscription. Now, looking at the subscription, I'm just saying I want to notify Cygnus of all changes. The important point here, I don't know if I highlighted at this point, the important point here is which port am I looking at? Because for Cygnus, it's the ports which align to which databases it's dealing with, and it's the Cygnus 5050 notify which I'm looking at. Because I'm persisting all the data, we'll get something coming in a bit. Yeah, we go. I do highlight that. Throttling, of course, is again useful because you might not want to have all your data in, and you might need multiple things here. And as you would expect, we now need to check to see, are we getting any data into the system? And you can see its status is active, which is good. Scroll that up, and you can see I'm receiving information. I've got some sort of time sent twice. It's been sent twice. And nothing else is going forward. Now, if I look directly into my database, because I'm using MySQL, I'm already nicely into my database. You can see data coming in through my lamps and what have you. I can run various SQL commands in the same way as I was doing. In the same way as I was doing with Quantum Leap, I'm now just looking directed to database, because this is standard data persistence. So this is just Oracle and just sending stuff to MySQL. I'm showing which database I've got. OpenIoT, of course, is because I've got that as the tenant. And you can see, because I've got my various devices doing things. You can see, for example, on screen, lamp 2 is off at the moment. It's received a table for each attribute, each entity, sorry, not each attribute, and then we can look in the structure of the actual tables you've created. The way that the Cygnus works here is that you can configure whether it's done by column or by row. There are multiple ways you can set things up, but I can work out, as you can see there, this is just saying, okay, every time I've done something, I'm saying I'm persisting all attributes. Whenever they change, it gives the attribute type, the attribute name, and the actual values. This is going 1 and 0 for the count. And you can see that I've got a lot of static data in there as well, which is probably absolutely useless because I had such a wide subscription in the first place. This is why you use data persistence components, is because you might not want all your attributes. Although, of course, this is a demonstration, so it's just showing the attributes which I've got. I'm not sure if I'm doing anything else clever here. I don't think I am. I think that's it. Oh yes, I do actually do one more query. So I can obviously reduce the number of columns and rows which I am getting hold of, because I can make requests as necessary. If you have a system which is in need of a SQL database, then obviously this is a good tool to do that. As I said, not all databases are served by both Draco and Cygnus. Cygnus generally has got a longer list, So, for example, DynamoDB, which is the Amazon endpoint, is Cygnus only. Stop sharing, start sharing. Draco covers basically the same endpoints as Cygnus. As you can see, it's Draco LD. The difference being this is Apache NiFi. So Apache NiFi is a more visual tool for doing this. You get little widgets which you can get data lines coming in. It doesn't have a port for each database. It just listens on one place. Now, this is preferred by a lot of people because you can see what's going on. However, it is slower to start up, and it has a shorter list of syncs. If you have a look at the previous list, which was here, you can see it's got CartoDB, CCAN, Hive, HTTP, Kafka, and this list has only got the Cassandra HDFS, MySQL, Postgres, CartoDB, and MongoDB. Sorry, so it's a matter of your own choice and how you want to scale these into production as to which one of these you would want to go for. So we're getting close towards the end now. Summary, and there's one line which is in red because this is something which beginners frequently get wrong, which is don't use a context broker as a database. It's not the job of a context broker to hold your information like a database. Yes, you can query and you can filter, but that's for entities and not for records in a database. Use a database to be a database. If necessary, persist your information. It's going to be the latest information, potentially, if you're doing something like the custom stuff, or it will be a historical record to get hold of a memory. Now, you've got Cygnus and Draco, basic use case is the same, or you can do stuff on your own. The point here is that your use case may or may not need data persistence. Most of them do, but what form of data persistence? Do you need to put a blockchain thing? Do you need to put in CCAN, whatever? It's flexible, and the idea of making it flexible is by having different components for each system. So only take what you need, and that also includes, and I need to stress this, that also includes the temporal interface. If you don't need it, you will get better performance if you don't include it, obviously, because there is a drag on the context broker if it needs to inform a database that something's happening. So instead of getting, say, 2,000 responses a second, you might go down to 1,500. You can get the actual numbers from the speed test repository from FIWARE to find out what the actual numbers are. I'm just making them up as I go along. Now, if you can do without it, do without it. And only add in a subscription as necessary and make the subscription as narrow as possible, because obviously that will impact your performance less. When you are worrying about your databases, you do need to consider these 5 or 6 points, because as I mentioned about 5 slides ago, this is your problem, not mine at this point, because you've decided which database to put into, where you want to do it. You need to have a storage policy. You need to have a backup policy. And these are things which will need to be within your architecture. It's not strictly context related when you're talking about disaster recovery or long-term storage or what have you. And then remember, if you've got things like GDPR, which is relevant to the legislation or authority you're currently based in, you may need to be able to delete lines if you've got sensitive data. And of course, with all of these databases, you can set up something like MongoDB to scale. You can use sharding. You can use scale stuff horizontally. You can have something in front of the database to put it to various different locations, or you could have something which is reading and other ones which are writing, so that you can get enough information beforehand. Properly architecting your databases is a completely different lecture, and obviously we should do this again sometime. But the context brokers do not offer this sort of thing directly, because it is such a diverse issue that it's not something which is strictly done by context broker. So this is the reason why we need to have these additional components for context data persistence. And that was the end of this part of the presentation. So I'll now be open for Q&A or any more detailed questions from the previous session. So thank you very much indeed. Any questions? We'll look at the chat. Don't think there's anything new on the chat. Anything on the Q&A? So if you want to, something through here. Okay. Are we able to create? Everyone asked me, so we can prevent. Are we able to create a device entity in the context broker, but link a remote data source? If the entity value is requested, then the command will be. I think, again, this is a more detailed question. Can we get, Christian, can you raise your hand and come up on stage? Because I think the answer to this one's no, but I'd like to know more details about what your thing is, because this is somewhere between the two presentations, isn't it? It's somewhere between devices and databases. So tell us more about about what you're trying to achieve.
At the moment in our company, we have an IoT backend installed, which we have some devices which are sending the data via MQTT to our backend, and we can request the data via MQTT. So, and I dislike to create a second data pool to where I have to copy each incoming request to the MQTT backend, and we have now, what I learned here is to create a data copy in the FIWARE infrastructure. But from my point of view, we have the data stored there, and we can request it there. But if we like to connect different systems together, then we can use the FIWARE infrastructure to define where a device is located and where the data is stored. And then we can ask the FIWARE infrastructure for data. And if this is really requested, then the request will be forwarded via MQTT to the real system, which is behind. Then we did not need to create two big things for storing the data.
Right. This is actually a relatively standard problem or issue or what have you. So you've got a real running live system. How can you attach a FIWARE on top of that? Now, because you're using MQTT, I know that some of the IoT agents are able to sniff the MQTT topics, for example. So it would be possible to leave your system as is. At the moment, it's got database, blah, 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 but also listen into that MQTT server and push this to the FIWARE system. The FIWARE system would then just hold the latest state of your devices or whatever, and you could use that just to, straight out with FIWARE to share your data with external systems. So in other words, it's just effectively you're just using a context broker as an additional interface you are offering. An alternative, there's always an alternative, is to, depending on your system, effectively you could say, okay, I will break that line between my MQTT system and database, is that right? And then you'd go through MQTT, IoT agent, context broker, and then database. The advantage of that is that then you have the flexibility to change as necessary. Disadvantage is that, of course, you'll need to reconfigure your running system. It's really a matter, in the end, of deciding what you want to change and update and break, because the idea behind the context broker is deliberately to split various layers of your architecture. And unless you split various bits of your architecture, you won't be passing the context data through a context broker. Therefore, you won't end up with a system which is powered by FIWARE. In other words, a system based purely on context. So it's a matter of working out your where you want to put this break. If you've got a fully, I mean, there's examples I know in the water domain which you've got a fully working system, and effectively all that we're getting is a regular upsert of files, and then we're just providing a view of the current state of the system. That's a perfectly legitimate way of doing it. If you want to introduce FIWARE in a bitwise fashion, that's the thing I'll do going forward. Does that make sense?
I think I will read the documents then, and then we will try it to do.
You can also, as I say, contact me and show me some diagrams, and I can try and get some more information. Yeah, for a Q&A, unfortunately, the answer to your question is it depends.
Okay, then
I'm being honest.
Learn and then perform. Thank you.
Yes. Okay, so I've got the next question, which is, are you going to bring this up again? Based on your experience, which time series data has the best performance with a data model structure proposed by FIWARE? Well, the one which I've seen most commonly used in NGSI installations is using quantum leap components rather than the STH Comet component. It's the quantum leap is able to use NGSI v2, whereas underlying within STH Comet is actually under the hood is using NGSI v1, which is the old version, and it goes via Cygnus to put additional information on. So that is a time series database. CrateDB works perfectly well. Within the context brokers, when they are using the temporal interface, there's quite a lot of systems. I think both Scorpio and I'm not sure OrionLD is using Kafka to put to. I mean, OrionLD pushes in the end to a Postgres database. I haven't seen the speed test results for all that. So I believe if you want to get the real answer rather than just what my belief and opinions are, the thing to do is to go onto the FIWARE GitHub, and I think there's a repository called Orion Test, something like that, where they're collating a load of performance data saying, okay, if we're running on a small system, it will do this. If we start sharding the database, it makes this difference, or what have you. I can't remember which size it was, but there was one configuration where you tried something, and you tried it also with database sharding, and database sharding made absolutely no difference whatsoever, because the increase in throughput you'd get from sharding was pushed down by the fact that you needed to do the sharding. So you ended up with a more complicated system without any performance gain. So look on the FIWARE GitHub/FIWARE and look at the test data to find out what numbers will work for you for your system. Any more questions, or did that answer your question? Since this training, bring this one up. Since this training camp is focusing on NGSI-LD, does this mean NGSI v2 is something that will soon get deprecated? No. There is a body out there which is already using NGSI v2, and you don't necessarily need NGSI-LD unless you want to benefit from linked data. NGSI v2 is more flexible, it is more stable, there are more tools out there which can support it. However, if you are looking to, and this is what the I4 Trust stuff is about, if you're looking to spread your data from one, say, local authority to another, or what have you, and you want to get that to a wider range of systems, then that's when you need to use linked data. And that's what this LD is. You could ask the same question in a more easy to understand format, is saying, okay, there's a data format called JSON. There's another data format called JSON-LD, linked data. And plain JSON isn't going to go away. But plain JSON is not going to get the benefits of linked data. It's precisely the same situation here, is that NGSI v2 is based purely on JSON. It's got the well-defined interface so that you will get things like the ability to rip out a component and put in another one in. You've got all the components within the FIWARE catalog which can push stuff to data. But you could, I could have done both of my demos for the Quantum Leap and the actually all three of them, Quantum Leap, Cygnus, IoT Agents. I could have done those all with the v2 because they'd all do that. And there are companies which tend to use v2 more than LD. I believe Telefonica, most of their components, most of their work is generally on the v2 stuff. So it's not going to go away anytime soon. Obviously, things will depend on the trends in data in the future, and FIWARE has obviously put a lot of emphasis on this concept of linked data. But all that the NGSI interfaces are is using the best practices of existing terminology, plus using this concept of a context broker for being able to break your system into manageable chunks. Anyone else with another question? If you're going quiet, then I think we'll be able to close here, and I'm sure I'll be back for another session soon.
So if no one have any question, then I will close the session and see everyone tomorrow at the same time slot.
Same time tomorrow, same channel.
So have a great rest of the day to everyone. Goodbye.
Thank you very much.